Have you ever looked at a geological map and just thought, what am I even looking at? It looks like some kind of beautiful but totally confusing abstract art. A mess of colors, lines, weird symbols. Well, what if I told you it's not art? It's actually a set of instructions for seeing a hidden world. So let's dive in and learn how to read the stories that Earth writes in its rocks. I mean, at first glance, what is this? It's just a bunch of colorful, wavy bands. It's flat, it's cryptic, and yeah, that question mark kind of says it all. Is this just some random pretty design? Or is it something way more profound? Could this flat pattern actually be a guide to the massive, three-dimensional world that exists right under our feet? Let's see if we can turn this 2D puzzle into a 3D reality. And that really gets to the heart of it. The big challenge here is translating a flat map into a three-dimensional story. How in the world do we use a simple piece of paper to understand the immense, complex geology of an entire landscape? Here's the fundamental problem, right? Our world is 3D, but our maps are flat. The layers of rock beneath us, they're not just lying there like a stack of pancakes. No, they are tilted, they're folded, they're even broken. And knowing exactly how they're oriented is absolutely critical. It tells engineers where to build a tunnel, or geologists where to find valuable resources. So how do they capture all that incredibly complex 3D information on a simple 2D surface? Well, they use a special kind of code. So let's crack that code. And I know it might look super complicated, but I promise you, you only need to really get two key ideas. Once you've got these two down, the entire map is going to open up for you. Okay, so the first concept is called strike. Let's make this really simple. I want you to picture a single layer of rock that's tilted. Now imagine that rock is sitting in a perfectly still lake, and the water comes up about halfway. You see the line that the water makes against the side of the rock? That is the strike. It's the direction of a perfectly horizontal line running across that tilted surface. And the second concept is dip. So if strike is the horizontal direction across the layer, dip is the angle going down the layer. It tells you exactly how steep that tilt is. It's the angle of the slope measured straight down from the horizontal. And here is, hands down, the best way to think about the direction of the dip. It's simply the path a marble would take if you just let it go on that rock layer. It's the downhill path. See? It's an incredibly intuitive way to picture it. So here's how those two ideas work together. You can see that horizontal strike line, and then you see the downward dip angle. Together, strike and dip give you the exact three-dimensional orientation of any rock layer out there. Now here's the best part. Geologists don't have to write strike this way and dip that way all over the map. They combine all of this information into one elegant, simple symbol. And this little T-shaped symbol is the key to everything. The long line, that's the strike, our waterline direction. That short little line that's perpendicular to it, that points in the direction of the dip, where our marble would roll. And the number right next to it, that's the dip angle, telling us the steepness of the tilt in degrees. One symbol gives you all the information you need. Pretty cool, right? All right, you've cracked the code. Now it's time to put your new knowledge to the test. Let's go from the flat map to a full 3D view and see what these symbols can really tell us. Okay, take a look at this map. You can see the different colored rock layers, and you can see our new friends, the strike and dip symbols. Now notice how the symbols on the left are pointing to the right, and the ones on the right are pointing to the left, kind of towards the middle. What do you think is actually happening underground? And there it is, the big reveal. It's an anticline, a massive upward fold in the rock. The dip symbols on the map predicted it perfectly. They showed us that the layers on both sides were dipping away from the center, creating this huge arch. The 2D symbols told the entire 3D story. So you see, the map isn't just some random pattern, it's a language. And with just those two key ideas, strike and dip, you can now read the unseen architecture of the world right beneath your feet. Okay, let's build on that. That was awesome. Now that you've got the basics down, we can apply this code to a much more complex and, frankly, more realistic landscape. Whoa, okay. This looks a lot more complicated, doesn't it? We've got our 2D map on top and the 3D block underneath. We've got different rock types, tilted layers, and there's even a fault line where the rock has completely fractured. This might have looked super overwhelming before, but now we can read it. Let's just break it down. First, the key on the right lets us identify the different rock formations. Okay, that pattern is conglomerate. This one is limestone. Easy enough. Next, let's check out our strike and dip symbols. We can see that this layer over here is dipping at a pretty gentle 25 degrees, but the one next to it is much steeper, at 35 degrees. And finally, you can trace that red fault line right across the map and then look down and see exactly how it fractures and offsets the layers in the 3D view. You're not just looking at it anymore, you are reading it. And this, right here, this is the ultimate goal. To be able to look at a flat 2D geological map and instantly visualize the incredible, dynamic 3D world that it represents. It's kind of like having X-ray vision for the planet. So the next time you're out there looking at a mountain range or a valley or even just a simple road cut on the highway, maybe you'll see it a little differently. You'll wonder not just what it is, but how it got there. And understanding that story, the story that's told by the rocks, is about so much more than just curiosity. It's how we find our water, how we build our cities safely, and how we understand the very ground we all stand on. So what story is waiting to be read right beneath your feet?